guys, welcome back to Rocket Gyan, my fellow space tubers. Hey, yeah. Okay, I am so happy to be back with you all guys, and finally we will be seeing another launch from the Wallops Island. This would be very interesting to see. The rocket would be Antares Rocket, which you are right now seeing on your screen, and the payload will be the obvious thing, the Cygnus spacecraft, and it will be going to the ISS. There are a lot of things to be, uh, you know, talk about right now, and we will get through each and everything. So, but before that, how are you all guys? It's been a long time since I have interacted now. It's like every stream which I, do, I have to say this because that's what happens. Sometimes my exam, sometimes the launch does not happen at all. So, yeah, that is the thing. Echo? Oh, it, just a sec. Have any echo? Let me see this thing. Just a sec. No, I don't think so. There is an echo. Yep, Scott, just check your whatever device you are listening to, maybe. Okay, because this is good from here. So, okay, yeah, reload. Fine. This is the Antares rocket which we are waiting for. This is right. This rocket is operated by Northrop Grumman, and talking about why this rocket came into existence. Basically, um, this rocket provide rapid and low cost access to space, basically low cost access to the space station. This rocket has around 8 tons payload capacity to low Earth orbit, so it's not like very heavy, which is evident obviously because it's a very small rocket too. But yeah, it does its job, so that is a thing. And oops, yeah. So talking about different stages of this rocket, well, this is a two-stage rocket. First stage is a liquid fuel, liquid fuel, liquid oxygen rocket, which means it uses RP1 and LOX as its fuel and uses RD-181 engine. So talking about these RD-181 engine, uh, this is how they look like. This is obviously are the Russian engines, and they previously used the AJ-26 engines, Aerojet Rocketdyne engines, but they were, more costly, were not able to produce rapidly. They were not being able to produce rapidly, as well as they had some corrosion issues with them. So they switched over to this RD-181 engines for their entire launch vehicle, and it had a huge success. And we know Russian engines are like great, great. They provide the engines are very low cost. It is like high in efficiency, and yeah, it does the job. And this talking about this rocket engine, it runs on stage combustion cycle, which means the fuel is combusted in stages, which means like in gas generator cycle, we have a pre-burner where the turbines are used to rotate from the means the gas is burnt in the pre-burner and then that is discarded, right? And that in the pre-burner actually does not have proper combustion taking place. But in stage combustion cycle, what happens is uh, the gases from the pre-burner are again then um, induced into the combustion chamber, and then again it is burnt there. So it's like stage combustioning happening there. So yeah, that is what we have. Talking about the second stage, so second stage is the Castor XL solid rocket motor. So this is very weird in this thing. I mean, we know that for the upper stages, obviously liquid fuel stages are much preferred because they are highly accurate and precise. But here we have the Castor XL solid rocket motor at the last stage, which is the upper stage. And talking about the accuracy and all those things, yes, the accuracy is very less for precise orbit insertion, but you don't want that because Cygnus spacecraft itself has its own propulsion system, right? Because it has to rendezvous with the ISS, so you don't want that. So if you are a bit off from your precise injection orbit, it's okay. Cygnus spacecraft will do the rest of the work. So that is the thing. So it's a two-stage rocket, two RD-181 engines, and one Kester XL upper stage, and then the fairing. And inside the fairing, obviously, the Cygnus spacecraft. Now, talking about the Cygnus spacecraft, there you go. This Cygnus spacecraft is being made by Northrop Grumman. This will dock to not dock. This will be berthed to the space station. The Canadarm will be berthing, and then it will be attached to the station, and then it will stay attached to the station for around 3 months, where it will perform the experiments, retrieve the all those cargoes which is going to the space station, the science and everything. And talking about the science and the cargo supply that it is carrying, so this is the thing which you can see. The total cargo capacity is 3,700 kilograms. Pressurized is 3,600 and unpressurized is 48 kilograms. So in this 48 kilograms unpressurized section, mostly they have this experiments or CubeSats which are exposed to the space. Unpressurized means nothing, which means they are exposed to space. Maybe not exposed to the space, but they are not pressurized. So but for the Cygnus, they are exposed to the space. And talking about the supplies, crew supplies, 1,300, almost 1,400 kilograms of crew supplies are going. Science, 1 tons of science is going. 15 kilograms spacewalk equipment, vehicle hardware, again 1 ton, and the computer resources 44 kilos. So this is the thing. Here you can see the solar panels and this is the service module basically, and this is the cargo section. So yeah, and this is the where the the birthing happened. This is that section. So yeah, that is okay. Do they buy them from a Russian company or license ability to make? No, they buy it from the Russia. They have this contract with them. Actually, the ULA Atlas 5 rocket also uses the Russian engines. So they have this contract. After the fall of the Soviet Union, their engines were exposed, you can say, and obviously their engines were much you can say of higher grade than US engines, but US engines had the F1 engine. So finally, F1 won the race for the moon. But talking about the efficiency and the performance, Russian engines were always better, and it is better till date right now. So yes, that is one thing. Okay. Now talking about the other things which we have. Okay, so let's have a look at this made in space kind of a thing. This is very exciting. This is one experiment which is going to the space. This is basically a space 3D printer. Okay, and this red wire regolith print, RRP, this is what they call it. RRP study will demonstrate 3D printing on the ISS using a material that simulates regolith, uh, the loose rock and the soil which is found on the surface of the planetary bodies. So basically, with this study will explore whether regolith could be used as a raw material in 3D printing in order to build structures during future space missions. So we already know that whenever we go to Mars, or first of all, we'll obviously go to the moon. So whenever we'll go to the moon, we want to utilize the in situ resources which we have on the moon, right? And this 3D printer will have those studies and will have those research which will eventually take us to make big printers which can finally do the 3D printing job on the moon. So this is like that. This will have a the cartridge. If you have your 3D printer at home or a normal printer at home, we already know that we have something called cartridge. Same thing happens with this. The cartridge is nothing but a simulated lunar regolith, you can say that, and that will be used to print things in space. So made in space is the company, and I think this is a private company which we are dealing with. So future is exciting indeed. Now moving on to the next one. First of all, I'm not covering each and every experiment which is going to the station. This will take a lot of time. I'm just covering, those main ones you can say. So yeah. Okay, the next one is, come on, load up. Yeah, this, the Kentucky re-entry probe experiments. Okay, so this is the re-entry probe experiments, and this KREP study will demonstrate an affordable TPS, which is nothing but the thermal protection system, which is planned to be used to protect spacecraft and their cargo during the atmospheric re-entry. Developing TPS on Earth is difficult as it is hard to replicate the unique conditions of re-entry through the Earth's atmosphere. So this is the thing, you can say that this is a new type of material they have devised, and now they want to test it, and it is very difficult to test it in earthly conditions because you can only test on Earth using some mathematical models, but obviously in-flight data is of much of greater importance. So this is one thing, this they have developed one affordable TPS system, and they will be testing it with this mission. Basically this testing for this KREP will happen when the Cygnus spacecraft will be departing from the station, and you will can see that this is actually inside a shell. This will be separated and this thing will be exposed, and then finally it will be tested. This will continuously, obviously this will burn up in the atmosphere because it will be kind of attached to the Cygnus spacecraft, but again it will, you can say, kind of will be transmitting the signals, or maybe it will uh, not burn up entirely. It will go through the plasma phase. When it comes out of the plasma phase, then it will start transmitting the signals for the sensor data which they have. So yeah, that's how that will work. We do have like other images also, you can see that here, shell inside the, yes. Okay, moving on to the next experiment, which is this. This is nothing but a four bed CO2 scrubber. Right now on ISS they use 4C CO2 scrubber, and this is nothing but to scrub the carbon dioxide which is produced. This will demonstrate technology which removes excess carbon dioxide from a spacecraft, and the investigation is based on the current system of CO2 scrubbing used on the ISS, but it will include mechanical upgrades and a longer lasting absorbent, or you can say the zeolite which is used, which will reduce erosion and stop dust from gathering. So it's, you can say, whatever CO2 scrubber they have, that's the 4C1, it will be a bigger upgrade for that CO2 scrubber. Okay, now moving on to the next one, and we have this one. This is Blob. Okay, this is nothing but a mold, and this involves students. So Blob is an ESA investigation which will allow students aged 10 to 18 to study a naturally occurring mold, or known as Blob, which you can see here. Blob is only a single cell, but it's capable of very basic forms of learning and adaptations. So what will happen is ESA astronaut Thomas will perform the experiment to see how the blob will, this mold will grow and perform in microgravity, and then all those time lapses and the data will be shared with the students on Earth, and they will have their own samples on Earth, and then the students aging from 10 to 18, just from 10 to 18, will compare it with the mold, or you can say the blob which they have on Earth. The data, they will be comparing the data, and researching on what how the behavior changes in microgravity. So yes, this is also one interesting experiment going to the space. Okay, I think this is pretty much about it. uh just a sec. Do have something, some other important hardware also going to the space station. Let me just tell you that. Okay, the hardware which is going is the ISS power augmentation mod kit, critical hardware to be installed during the upcoming ISS rollout solar array spacewalk. So This is a power augmentation kit. Then we have airlock storage platform going in, the avionics air assembly fans, the oxygen generator, the commercial crew vehicle emergency breathing air assembly, which is nothing but if there is a emergency in on space station, then the crew are advised to go inside their escape pods, which means they're, the crew dragon, or in future starliner, hopefully they are advised to go in there, and they need to have some resources inside the cargo dragon also, like, sorry, the crew dragon also. So this commercial crew vehicle emergency breathing air assembly, as the name suggests, will be available to the crew, so that if there is any emergency they can take up that. This is like, the oxygen cylinder, you can say that, kind of that, and take that inside the Crew Dragon and survive whatever, if they are, in that situation. Then the waste management installation in space, spare hardware, and the air tanks. So this is what is going to the station today. Okay, moving on to the next thing. And as we all know, Cygnus spacecraft, the Cygnus mission, the Antares mission, is always been dedicated to someone from their previous from dedicated to someone who has done some incredible things in space. So this is the NG-16 mission, which is today's, is named after NASA astronaut Ellison Onizuka, if I have pronounced it all right. He was the first Asian American to fly to space, and he was selected for NASA astronaut training program in 1978. He first flew on a mission as a mission specialist on board the Space Shuttle Discovery for STS-51C mission, where he was responsible for primary payload activities, and he completed around for 74 hours in space, and then finally he came back to the to to the uh, Earth. But Ojinaka later flew an STS-51L mission, but he and the 6 other crew members tragically lost their lives when the Space Shuttle Challenger, we all know, exploded 73 seconds after the launch. And Onizuka paid the ultimate sacrifice, but has left an important legacy that continues to inspire younger people around the world. So this mission is dedicated to him. We all know that Challenger, an incident was a bit drastic, and it's good to have some, you know, dedication of missions to the crew member. Okay. Now talking about the interesting part, which is how you can view this launch, right? We all want to see. So if you are living in Wallops, then you can view this launch around Wallops, not exactly in Wallops, but around Wallops. Then you can view this launch, and this map suggests that you can see that in 10 to 30 seconds, this blue area, you'll be able to see the launch, which means after t plus 10 to t plus 30 seconds, you live here inside this blue area, you'll be able to watch accordingly. For this pink area, t plus 30 to 60, and then t plus 60 to 90 second in this yellow, and then finally t plus 90 to 120 in this area. So this is the visibility map you have. And talking about the best places to view the launch, if you can go out and see that, if you live nearby, I also have that list for you. This is there's 5 places to watch a Wallops launch. Sorry for the quality, but this was the best one which I could find. This is the Wallops launch range. This is the one which is the nearest one, and you will get the best view, which is from the Kinkotig Island, if I pronounce it all right. Then we have the Assateague Island on this Maryland. Then we have the Ocean City in Maryland and Delaware Seashore. These are the 4 location, and then finally the Virginia Beach. As always, this is like 70 miles away, but again it gives a good view of the rocket. So these are the 5 places to watch for this launch. And if you live nearby, I would definitely suggest that you go to these areas and take a look at this amazing launch which will happen today. See now what is the status of stream. We do have time left. If you have anything you want to ask, you can ask me now. Just pull up the video feed for you. There is, I mean, the quality is so poor. I don't know what will be the quality when they will switch over to the NASA team, but right now the quality is so poor. You can see that. And right now we can see the Antares rocket is venting, which is obvious because of its cryogenic fuel it uses. And yeah. How are you? Looking forward for today's launch. Hi, I am Rove. I am fine. How are you? Um, Outer blue ring seems a little short. This is an orbital launch. Basically, it's you can actually see the rocket from far away places. So this is an orbital launch, and you should be able to see. Uh, the engine with the pre-burner also working as an expansion chamber. Okay, so not the expansion, but I think you wanted to say combustion chamber. No. Uh, See, the combustion which is happening in the obviously combustion is happening there, but the combustion which is happening in the pre-burner is not fully what do I say? Optimal. Yeah, optimal is the good word. It could be oxidizer rich or fuel rich, and this is I'm is not optimal. By what I mean by non-optimal optimal. It is nothing but that you have some unburnt fuel in that, and the only reason why we have a pre-burner is to rotate the turbines so that it rotates the turbo pumps. I have explained this thing in my video for the Delta 4 Heavy, how the things work. This is like a chicken and egg problem. You need to rotate the turbines first in order to rotate the turbo pumps, but turbine actually needs pre-burner to function in order to rotate turbines, but pre-burner actually need the turbo pumps to rotate first. So it's like, you know, a thing which is a chicken eggs in problem, you can. And that problem is basically solved using helium as a initiator to initially provide that you know rotation to the turbines, and then finally the stable configuration is established for the flight. But I meant expansion to allow the gases to expand before actual burn. Okay. uh, mm, I won't say that. The expansion is basically I would say expansion is happened mainly in after the fuel passes through the injector plate, because then surface area is actually fully increased, and there the combustion also happens. So yes, but pre-burner is just a you know a non-optimal burn wherein you need to have it in order to rotate the turbines. I know, John. I mean, this is a thing which we all are waiting for. The rocket launches are always a delight to watch. How much of the ISS resupply market is contracted to SpaceX versus others like the Northrop? Okay, so talking about the market for the commercial commercial cargos, basically commercial resupply mission. This is divided into, you can say, availability of of the things. Basically, you have Dragon, then you can go with Dragon. Then you have this Cygnus, you go with Cygnus, and every other this you say spacecraft has its own abilities. Like you can bring the experiments back with the cargo Dragon, but you can't do that with the Cygnus because it burns up in the atmosphere. Since it burns up in the atmosphere, that means you can stuff it up with all the waste and everything, and it finally burns up in the atmosphere. So all of them has the different abilities, and you want to, it's like a cycle going on in ISS. you want at this date you want the waste to be removed, so you want a module which is attached to the station which can take up waste and then finally take it off. So it's like that. Okay, and talking about the contracts, if you know, it's not like someone is preferred over someone else. Whoever is available, you give the contract to them. And talking and the and how the mission can say requirements are, according to that they are decided. I think there is some glitch. good with my good with my signal. Yes, we is from NASA. And guys, if you like what you are seeing, then just hit the like button, and if you want to support me, you can do that by becoming a Patreon. Link is down in the description, or just click on that join button and it would really help the channel. Next general EV space suits is detailed and won't be ready until the April 2025. Yes, that's a very sad news. Exactly. Um, this okay. We do have this. Just a sec. Let me just. Okay, this is much better. This is indeed much better.
Cargo spacecraft, carrying more than 8,200 pounds of research, crew supplies, and hardware to the International Space Station. The launch time today was moved to the back of the launch window after teams detected an apparent helium pressurization valve leak on the vehicle. The issue was quickly resolved, and everything is on track for a launch today at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time. Fueling for Antares began at 3:45 p.m. Central Time today and now stands ready to send Cygnus to the International Space Station. Currently favorable weather conditions today for launch with mostly sunny skies, and the temperature at the launch site today is 83 degrees Fahrenheit. Each Cygnus spacecraft is named after influential individuals in the world of spaceflight, and the Cygnus spacecraft for this space station resupply mission is dedicated to former NASA astronaut Ellison Onizuka, who they selected in honor of his prominence as the first Asian American astronaut. Onizuka was hired in 1978 in the first class of diverse astronauts, and his first spaceflight was aboard Space Shuttle Discovery in January 1985 for STS-51C. He lost his life aboard the Space Shuttle Challenger in 1986, along with 6 other crew members.
External power on, and FTSB, external power on.
So right now everything is looking good.
External power nominal. And a copy all. Check 367, 368.
Cygnus will arrive to the International Space Station after a 2-day journey on Thursday, August 12th, where it will be installed to the space station's Unity module. NASA astronaut Megan MacArthur will use the Canadarm2 robotic arm to capture the Cygnus spacecraft, backed up by Thomas Pasquet of the European Space Agency. After Cygnus capture, controls will be turned over to Mission Control Houston, where ground controllers will send ground commands for the station's arm to rotate and install the cargo spacecraft on the Earth-facing port of the station's Unity module. The Cygnus spacecraft is scheduled to remain at the space station until November, when it will depart the station, disposing of several tons of trash during a fiery re-entry into the Earth's atmosphere.
And FSO, you're good to send FTS receiver arm command for 2 seconds, then remove. Continue check channel when function removed.
This is FSO, arm on my mark. 3, 2, 1, mark, +1, +2, arm removed, check channel continued.
LCLAC-2, FPS arm indication received.
Teams around the country are working together today to ensure various systems are a go for launch. Northrop Grumman teams in the Antares Launch Control Center in Wallops Island, Virginia, are monitoring systems on the Antares rocket. And once Cygnus separates from the Antares rocket today and reaches its preliminary orbit, controls of the vehicle will be handed over to teams at Northrop Grumman's Mission Control Center in Dulles, Virginia. Teams there are being led by Mission Director Teresa Spinelli. And
Yes.
back in the International Space Station Flight Control Room in Houston, Texas, flight control teams are being led by Flight Director Greg Whitney. Teams here are monitoring systems on the International Space Station, ensuring all systems are a go for Cygnus launch today and arrival to the International Space Station. And so far, all teams are a go for launch today at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time.
You heard it right, Wildflower. They will fill it up with trash because then it will burn up in the atmosphere. So that's how the trash is disposed of in the International Space Station. So you literally, if it burns over your head, you are, uh, you know, you are breathing and everything. You are actually breathing in all the waste and everything which, is disposed of, burned off in the Cygnus spacecraft. So right now the weather is 80% go for the launch. Things are looking very good for today's launch, and as they said, there was some issue with the valves and everything, but sorry, the helium thing, but the issue has been resolved very quickly, and now they have moved to the end of the launch window at 6:01 p.m. EDT.
And joining us for today's launch broadcast from Northrop Grumman is Antares System Engineering Program Manager Christina Halona, and she'll be walking us through some of the features and milestones for today's launch. Christina, the launch was moved to the back of the launch window today. Can you explain what the teams detected on the ground and how it was resolved?
Hi, Courtney. Sure. So during our pre-launch checkouts, we detected an anomalous reading at the pad. So our Mid-Atlantic Range Spaceport and Northrop Grumman teams had to troubleshoot the issue out at the pad, which actually required our teams to physically inspect the pad. So after we had previously already cleared out of the pad for safety issues, obviously, so we had to get back out there and check out and make sure everything was up and running and everything looked good. And so that actually took a little bit longer than expected. So it took us to the tail end of our launch window. So everything looked good, and we're ready to go for launch.
HS1 is go.
Okay, we're ready.
Yes, and we're looking live now at the Antares Rocket, standing ready to launch a Cygnus cargo spacecraft carrying more than 8,200 pounds of research, crew supplies, and hardware to the International Space Station. Christina, can you tell us more about this Antares 230 Plus rocket's capabilities?
Sure. So the Antares 230 Plus vehicle provides substantial payload performance into a variety of low inclination, low Earth and Sun synchronous orbits and interplanetary trajectories. So our Antares has actually been upgraded. Our Stage 1 core, which has a lighter composite structure and an optimized second stage motor. The upgraded Stage 1 core allows the Antares engines to perform at full thrust throughout most of the first stage profile. The 230 Plus vehicle also has a cargo mass flexibility, in which the Cygnus mass can be defined no later than 24 hours prior to launch. The Antares 230 Plus vehicle also has the ability to perform late load operations by the unique pop-top fairing as the nose of the vehicle is able to remove for the late cargo load.
And opening valve ED21 on my mark. 3, 2.
And the vehicle rolled out to the pad Friday, August 6th. It was then rotated horizontal for some late cargo, like you're saying now, and then it was returned to its vertical position where it sits now yesterday. So, Christina, can you walk us through the cargo late loading process and late load capabilities?
You can resume your...
Yeah, sure. So as I mentioned before, one of the unique features of the Antares 230 Plus vehicle is that there is the ability to do a late cargo load 24 hours before launch. The vehicle has a pop-top fairing where the nose of the rocket is able to be removed. Northrop Grumman has also built new specialized ground support equipment that allows us to take the vehicle from vertical, like you see it out the pad, and take it back horizontal, which we did previously, actually last night. So this allows us to drive what we call a mobile clean room right up to the tip of the fairing, where we are able to remove the pop-top fairing and load time-sensitive research experiments and other perishable items that NASA needs to provide 24 hours before launch. And so with all this talk about cargo, the Antares vehicle is carrying approximately a little over 8,200 pounds of cargo to the space station aboard the Cygnus spacecraft today, which is actually our largest resupply to date. So we're very excited about that. And we at Northrop Grumman, we're really proud of our Antares 230 Plus rocket and the Cygnus spacecraft, and we're dedicated to continue to providing the best value to our customer in support of their critical missions.
And just going off of that, Antares and Cygnus have now been part of the chain of resupply for the International Space Station for several years now. How crucial has Northrop Grumman's role been in contributing to that?
So Northrop Grumman has played a critical role in keeping the International Space Station operational since 2013. And this was apparent with NASA awarding Northrop Grumman 2 additional commercial resupply missions to continue to deliver cargo such as food, hardware, science experiments, and other necessities. And Cygnus is unique in its ability to carry away large amounts of pressurized cargo, a critical function for NASA and the crew aboard the ISS. With these additional awarded flights to the orbiting laboratory, Northrop Grumman will provide services to both NASA and our commercial partners to continue to use Cygnus not as just a cargo delivery and disposable vehicle, but also as a platform for science and technology research and development opportunities. And since 2013, Northrop Grumman has been a trusted and reliable partner to NASA, and we look forward to this continued partnership into the future.
You go to activate arm enable.
Cool.
And now teams have been running through some pre-launch milestones today, and they'll continue to run through those through launch. Can you tell us a little bit more about the fueling process?
Yeah, so I'll just go through the entire ascent,
And
actually.
we have, this is good.
When Antares, we'll have a stage of ignition at T0, and we'll lift off shortly after. The main engines will burn off for approximately 200 seconds, and that will get us to main engine cutoff, which we call MECO. And then once we get to MECO, we'll go into a short coast right before we separate stage 1 from stage 2, which we call the upper stack portion of Antares. We'll continue to coast a little bit longer, about 30 seconds before fairing separation, and then we'll have an internal separation where the stage 2 flies out of the...
So thank you so much, EF, for your $2. And okay,
burn that puts Cygnus real close to their orbit. And then we'll coast and then Cygnus will coast a little bit to ensure everything is stable. And then Cygnus will be released into the desired orbit. So after Cygnus is released, we'll go through comm checks, and then about an hour or so after we separate, Cygnus will release its solar arrays and be on its way to the International Space Station. And I believe you at NASA, you guys also showed the solar arrays deployment sometime, so you guys all might get to see that again later. But in summary, it takes approximately Cygnus 9 minutes to get to orbit, so it takes some time, but it is pretty fast.
Well, Christina, we're looking forward to welcoming Cygnus aboard the International Space Station, and of course, we'll have you back to join us after launch as well. So do you have any final words before launch today?
No, I don't. Go Antares and go Cygnus.
All right, thanks, Christina. You just heard from Northrop Grumman, our Antares System Engineering Program Manager, Christina Halona. Stay tuned after launch for a post-launch interview with Christina again, and an interview with Jeff Arend, NASA's Systems Engineering Integration Office Manager. Again, mostly sunny skies for launch today back at the Mid-Atlantic Regional Spaceport at NASA's Wallops Flight Facility in Virginia, and temperatures are now about 83 degrees Fahrenheit at the pad.
Oh, I hope, Jacob, you get your job at Northrop. That would be so cool. We are right now T-minus 19 minutes until the launch. Everything is looking good, and yes, that was, a thing which I had to talk. You can see the last donation can't appear right now. Yeah, we are T-minus 18 minutes the launch, and everything is looking good. Talking about the viewing area, if you live nearby Wallops Island, you can view this launch, and I would very much like you to go and view it. So this is the visibility map. You can see here T plus 10 to 30 seconds. The inner blue is the thing. Just a sec. Inner blue is the circle, and then the pink, and then the yellow, and then the blue. So this is your visibility map. Take a screenshot of what if you live nearby, and then go out, watch it. And there is some delay, so go at around T-minus 2 minutes until the liftoff and start looking up into the sky.
98 pounds of computer resources. Cygnus will also carry a new mounting bracket that astronauts will attach to the port side of the station's backbone truss during a spacewalk planned for later this month. The mounting bracket will enable the installation of the next pair of iROSA solar arrays at a later date. Now let's take a quick look at some of the scientific investigations traveling to the space station on this mission.
Okay, sending slime molds, regulate stimulant, new science hardware, muscle cells. Yes, I already told you everything. Okay, I don't think so. I can have this thing play because of the the music. Okay. Outer blue ring is too thin. Okay. Oh, and talking about this launch. Okay, so this 3D printer I already told you. And talking about this launch, guys, just after the launch, after t plus 0 seconds, or you can say t plus 1 second, when the rocket lifts off, you will see that rocket actually performs some sort of a tilt, or some sort of sideways movement. And that type of maneuver which rocket performs actually is known as something, and that is known as Baumgartner maneuver, if I'm not wrong. And you will see that when this rocket will launch, it will just move us sideways a little bit, and it will perform that maneuver. And why does that, why does it perform this? Think right now, and I will tell the answer after the launch. So yes, this mold thing, this blob, is actually dedicated to the students. So that is pretty cool. Wildfire smoke in the atmosphere across the. It just do that maneuver just after the liftoff. You just see it, and then guess your answers and what, and then tell me.
New experiments, but they'll also have some extra goodies arriving. Also flying on Cygnus today are some treats for the crew, just to name a few. The crew will be receiving apples, tomatoes, kiwis, pizza kits, and cheese assortments.
CMD. Yeah, you're good. Transfer Cygnus to launch mode. In work. Copy, in work.
And 3, 2,
Coming
1.
up on 15
Yay.
minutes from launch today, all systems are still on track for an on-time launch today at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time.
Can you provide status of trajectory file for launch operation?
LC GNC1, trajectory file does not require an update.
Copy that. We'll check 403. And Ops 1 404 not required today. 405 not required.
Copy LC.
Yes,
And Core 1 LC, countdown 1.
also
LC,
require
I've
those
got
plus
step
and everything.
394 for you. Fuel level does not require adjustment.
Roger that. Prop 2, step 395, arm OCCS for no adjustment to fuel level.
And OCCS AC/DC armed. AC/DC confirmed.
Copy. Check 395, 396.
And OCCS configured for no adjustment to fuel level.
Check 397. Admin be advised, step 398 not required. Step 399 not required.
They are just calling out those normal mission.
Coming up on T-minus 14 minutes, we'll be polling for our final countdown in about a minute and a half.
In control call outs, the standard mission call outs. And yes, though that 3D printer is game changing. Once that is will be using the regolith, the simulated regolith, which can be found on Moon as the cartridge to print structures.
We'll conduct a poll to proceed with the final launch countdown. In about 5 minutes from launch, the vehicle will switch to internal power.
There you
Then
go.
just about 3 minutes and 30 seconds before launch, auto sequence handoff for terminal countdown will be initiated, and that will mark the time the computers take over for the final milestones before launch.
054, 055, 056.
LC CMD on countdown 1.
Flight pressure.
Stand by CMD.
And so those constraints will be waived from 4,000 to 3,850.
I guess someone else has to donate in order to.
And go ahead, CMD.
Okay.
Yeah, CMD. Cygnus is in launch mode and nominal.
Roger that. We'll check 407 complete. And launch team LC on countdown 1 with poll to proceed with final countdown. GSO.
go.
RSL.
RSOs go.
TD.
TD's go.
Prop lead.
Prop leads go.
Stage 1.
Stand by, LC.
MES1.
MES1's go.
GCE.
GC's go. Sorry.
ACE.
ACE's go.
Mars.
Mars is go.
CMD.
CMD is go.
NLD.
I'd like to hear from Stage 1 first.
Yep,
Stage
stand
1
by.
is go.
Stage 1 is go.
LD is go.
NG.
Northrop Grumman is proud to honor accomplished NASA astronaut and the first Asian American in space, Ellison Onizuka. In our current challenging times, we reflect on Ellison's inspirational words. The people that make the world run, whose names will go down in the history books, are not the cynics, the critics, or the armchair quarterbacks. They are the adventurists, the explorers, and the doers of the world. When they see a wrong or a problem, they do something about it. When they see a vacant place in our knowledge, they work to fill the void. And today, we will do just that. Aloha to the SS Ellison Onizuka. Northrop Grumman is go for launch.
And I copy. We're go to proceed with final countdown. Check 407. Fly high, Ethan. Ops 2, step 408. You're go to start engine evacuation.
LC Ops 2, engine evacuation started.
And you just heard the poll to proceed with the final countdown to launch, and all teams are polling a go. And of course, a
Okay.
tribute to Ellison Onizuka, who this Cygnus spacecraft is dedicated after.
That is cool. So guys, just type in the chat from where you are watching this launch. Let's see our diversity of our audience today. So T minus 10 minutes and 20 seconds. We just heard the poll and everything is looking good. We are go for the
Now
launch.
coming up on 10 minutes away from launch, and everything is still proceeding smoothly for launch at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time.
Passing T minus 10 minutes.
They are like changing the time of the launch. Seconds, 3 seconds. In.
Once we get to that launch time today, the first thing that will occur is the Stage 1 ignition, and you'll see liftoff just a few seconds after that, and those main two engines will burn for about 3 minutes and 18 seconds before cutting off, and Stage 1 will separate. Cygnus will coast for a bit until fairing separation, when the external cover that protects the spacecraft during launch will separate. The interstage adapter that connects the first and second stages will separate at about 4 minutes into flight, and
Okay, so we have people from North Carolina, Texas, Haverford, Greece, Red Springs, Finger, Canada, Vancouver, Montreal. So yeah, we do have people, watching all over the world.
At the time of launch, the International Space Station will be flying 260 statute miles over the southern Indian Ocean.
ACS VDMs enabled, voltage nominal, ODM command.
If you saw the sounding rocket, Sean, you should be able to see this launch also. And Edinburgh, Scotland. Hi, Octograbber. Well, too bad subtitles are off, and so I can't hear anything. For live streams, we don't have the subtitles actually, Camp.
Now just about 8 minutes and 30 seconds to launch. Again, that next milestone we'll hear will be for the vehicle to be turned to internal power at 5 minutes out.
Jay Brown, I would suggest you to go out and see the launch. You should be able to see the launch if you live in Delaware. I must say that. And for one last time, I'm pulling up the visibility map for all of you to see. This is the visibility map. Take a screenshot. All of you, you can see that at T plus 10 seconds, you should be able to see the launch from the inner blue circle, and then
And we're
pink,
at T minus 8 minutes.
yellow, and then big blue. So this is the visibility map. So yeah.
LC flight control, GN2 conditioning initiated.
And I copy GN2 conditioning initiated.
Mexico. Hey. Okay. We have something from someone, and thank you so much, someone, for that too. Right now, the venting is going on, which is, the high venting, which means they are clearing up the pipes and doing up the last top of the vehicle. Okay.
Passing T-minus 7 minutes.
Now, inside 7 minutes, you've been hearing teams running through some of these final milestones, and the internal power has been activated. Again, it'll be switched over to internal power at the 5-minute mark.
Okay, copy. And when you come back up in 4 minutes, will you be ready to roll?
Hope so. Stand by.
Okay, copy that.
LC prop lead, VTSO activation verified.
Roger that. Check 414, Ops 2, initialize ground ordnance power supplies.
LC Ops 2, ground ordnance power supplies initialized.
Ground ordnance power supplies nominal.
Check 415 and 416.
So guys, I know what is going on in the chat, but yeah. It was worth it. Okay, cool. So we are T-minus 6 minutes until the launch. Everything looking good. We have the Antares, how do we pronounce? Rocket on the pad, looking good. It is venting properly right now with RP1 and LOX as its fuel, so it's like topping off liquid oxygen right now.
FA ECS transfer to GN2 confirmed.
Copy that, site control. Check 417.
Okay. ICBM with cheese. This was supposed to be, no, not this one. Not ICBM. You can say it used to be when it was using AJ26 engines, but now RD181 engine replaced it.
T-minus 5 minutes. Ops 2, you're go to initiate engine priming.
Engine priming started.
Okay,
Ops
guys.
1, transfer avionics to internal power.
Let's have our focus on this rocket now.
All internal power on. Standby 5. And all external power off.
So they are moving
internal power is nominal.
To the
Ops
internal
1,
power.
open FTS umbi loop.
FTS umbi loop open and green.
High termination system is, you can say,
You just heard those calls to initiate internal power for the vehicle, so internal power is now on, and all systems are still proceeding on track for launch just 4 minutes from now.
3, 2, 1, mark. Arm command sent.
SNAs, ODMs, all armed.
Copy that. T-minus 4 minutes.
Okay. The time is coming close now. 3 minutes and 47 seconds left.
Step 426, priming verify.
Copy that. Check 426 complete.
They are launching apples as well as pizzas also. Women's West. So you can have a snack
TD, I'll
off
wait for your
that
report on
too.
range status.
LCTD, we are green.
Copy, range green. Check 425.
This is what we want to
Step
hear.
427, not required. Phase 3 dynamic limits will be active at T-minus 3 minutes.
T-minus 3 minutes, 11 seconds.
FC commanded to flight mode.
It
Check
is in
429.
internal power and waiting for the liftoff for the final checks.
Auto sequence start.
And there are so many things.
LCTD, we're green for all systems. Green for all systems.
ODM bus voltages and currents nominal.
Copy like one, and I copy. TD, we'll check 430, 431. GNC 1, verify ready for nav mode.
LC, GNC 1, Orb nav ready for nav.
Ops 2, step 433, switch to nav.
LC Ops 2, Orb nav, switch to navigate.
2 minutes and 30 seconds to launch, still counting down to that exact liftoff time at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time. Tanks will be pressurized at about the T-minus 40 seconds until liftoff, and we'll be counting down to liftoff from there.
Guys, again reminding, it's T-minus 2 minutes left now, and if you all live nearby, you should head out and look according to the map. And guys, remember that question which I asked. There is one thing which this rocket performs just after the liftoff. It moves a bit sideways. If it is visible from this angle or not, we'll see, but look out for that and give me the answer. Why does it do that? So yeah, T-minus 1 minute and 40 seconds until the launch. Things are looking very good right now. Everything is looking good. The vehicle is topping off with the liquid oxygen. Okay, this is happening.
T-minus 1 minute, 30 seconds.
And this is happening now. Okay, T-minus 1 minute. Okay, this is happening. Everybody stay calm. Stay calm. You know what I mean. T-minus 1 minute.
T-minus 1 minute. Mark.
This is looking good. T-minus 50 seconds. Everything is looking good. Everything is green. Every step has been performed right now. And now the topping off has stopped. Everything is looking
40 seconds
great.
until liftoff.
40 seconds left. And let's light this candle, guys.
T-minus 30 seconds. Mark. T-minus 10.
8, 7, 6,
5,
4.
4, 3,
Okay.
2, 1.
And ignition and lift.
Start. And we have liftoff of Antares for the NG-16 mission, the Wallops Flight Facility.
Whoa.
Engines at 100%. Attitude nominal.
There you have it,
The
guys.
SS Ellison Onizuka now on its way to the International Space Station to deliver more than 8,200 pounds of cargo. Good first stage performance so far.
Wow, this looks so beautiful.
AV and power subsystems are nominal.
Whoa, see those RD-181 engines glowing in.
All systems are nominal.
Everything is
At
looking
100%.
nominal. What a weather to see this long.
Duration of stage 1 burn is approximately 3 minutes and 18 seconds. Currently at 65 seconds.
You can still hear the sound coming out of it.
40,000 feet, passing max Q.
First stage now passing through the area of maximum dynamic pressure.
Things are looking great right now.
Again, this first stage will burn for about 3 minutes and 18 seconds until main engine cutoff.
All subsystems continue to perform as expected, passing 70,000 feet.
Okay, actually the countdown had some issues with them, but okay.
Mission
Plus 10
time
seconds.
plus 110 seconds.
We can see those RP1, plumes coming out of it. Obviously, that's how it looks like, because it has that carbon in it.
Engines continue at 100%. Core pressures nominal. All vehicle subsystems nominal.
Who is
Passing
approaching?
120,000 feet.
Won't happen right now. It's still like
2
1 minute
minutes,
to
20
go.
seconds into flight, everything still proceeding nominal.
1 more minute.
Eco to happen. It is looking so beautiful. Indeed. Must say that.
Attitude nominal. All G and C performance as expected.
See, it's like only the first stage does the job. I mean, it's like propelling it for so long. T plus 3 minutes and 18 seconds.
Antares performance continues nominal.
The first stage propels the spacecraft to the orbit. Like a very long burn for the first stage.
Throttle down to 80%.
Exactly.
Throttling down 3 minutes into flight. Main engine cutoff coming soon.
Main engine cutoff coming
Throttle
soon.
down to 55%.
Now you should be seeing that.
All systems nominal.
Main engine cutoff. There you go. We have
Stage
MECO.
1 MECO.
Stage separation confirmed.
We have main engine cutoff. Antares entering into a co-stage, standing by for stage 1 separation.
Then stage 2 ignition.
Stage 1 separation confirmed.
There is still, a coasting phase there. The stage 2 does not ignite as such. You can see it from here only. There is a coasting phase. First of all, now the fairings.
In coast phase.
Fairings will open up. Then there you go. The fairing should open up.
Fairing separation.
Fairing separation confirmed.
Interstage separation confirmed. Should happen now. And the second stage.
And we have stage 2 ignition.
There you have it. Perfectly in sync.
Stage 2 will burn for roughly 2 minutes and 30 seconds. All systems continue nominal.
Stage 2 ignition is confirmed. Stage 2 is that solid rocket fuel that will burn for about 2 minutes and 45 seconds. Burnout will come at 6 minutes and 52 seconds into the flight today. And as we lose sight of the vehicle, we're now switching to animation.
4.5 kilometers per second. Altitude approaching 140 kilometers.
We have the data right on our screens. The altitude 89 miles right now, or 140 kilometers, well above the atmosphere. Velocity
now 5 minutes into flight, everything proceeding smoothly.
4.6 kilometers per second.
Burn continues.
4.9, okay.
Approaching 150 kilometers in altitude.
Okay, this is looking good. Looking real good. Apogee 176. We can still see the perigee at minus something, which means it has not attained orbit till now. Because the velocity is also like 5.6 kilometers per second. The the orbital velocity is close to 7.9 to 8 kilometers a second. So we'll have to wait till that. And occasional
1 minute to stage
blue thing you can see on the rocket is the attitude control system firing. Yes.
Altitude 170 kilometers. All systems continue to perform as expected.
Performance as expected. That's what we want. Okay.
Approximately 30 seconds to stage 2 burnout.
And remind you, this upper stage is a solid rocket motor, which means they don't have any liquid fuel as an upper stage. So their accuracy may not be perfectly good, but obviously they should be. And now they are well above the atmosphere. So they are in the stable orbit.
Stage 2 burnout.
Burnout confirmed.
And stage 2 burnout is confirmed.
There you go.
For approximately 2 minutes till spacecraft separation.
Yes, Edgar, the Kerbal Space Program is there.
Altitude nearly 180 kilometers.
It is too late for me
Attitude
also,
nominal.
Wildflower. It's like 4 a.m. here. So I'm streaming it and I'm feeling sleepy also. So you may not experience that much of energy right now, but okay. And I do have an exam tomorrow. Yes. Okay, cool.
Attitude nominal. Antares continues to orient and prepare for spacecraft separation in a little more than 1 minute.
We're seeing the spacecraft separation anytime now at around T plus 8 minutes and 9 minutes, and should be seeing the spacecraft separation happening. Oh, sorry, 8 minutes 52. So the orbital parameters, we can see that the apogee is around 41 kilometers and perigee is 174 kilometers. So it's not at
altitude 179 kilometers.
The perfectly circular orbit, which is expected also.
Roughly 30 seconds to spacecraft separation.
Standing by for spacecraft separation.
Attitude nominal.
Spacecraft separation confirmed. There you go.
And we have spacecraft separation. Go Cygnus.
Spacecraft separation confirmed, and Cygnus has separated from the second stage. And Northrop Grumman teams now celebrating the confirmation of spacecraft separation.
LC with that, flyout calls are completed.
Copy that, Ace. Okay, launch team, let's maintain protocol on station here. We're in our post-launch checklist. Prop 1's already given us step 444. Pulse purging is in progress. And GNC1, I'll wait for your call on status for step 445. State vector.
LC GNC1 in work.
And I copy in work. And site control, step 446, you can remove aft bay GN2 flow and reconfigure ECS to post-launch.
In work.
Core 1 LC, step 447, direct personnel to power off the MS ground equipment and report when complete.
Yeah, copy that, LC. We'll get that in work once personnel.
And we have confirmation for the Cygnus spacecraft separation, and finally you can see that everyone is happy because the Northrop Grumman, you can say that their half work is complete because now they have to operate this Cygnus spacecraft also. So yeah, that will happen. What was that? These are the solar panels.
With
Yes.
confirmation of successful orbital insertion, Cygnus is now on its way to the International Space Station, where it will arrive in 2 days on Thursday, August 12th, to deliver more than 8,200 pounds of cargo. Back with us now from Northrop Grumman is Antares System Engineering Program Manager Christina Halona. Christina, what will the Northrop Grumman teams in Dulles do here on the ground between now until Cygnus arrives to the space station?
Yeah, so the Northrop Grumman teams in Dulles has quite a few things that they'll be doing. So they operate the Cygnus spacecraft basically now that we have been released from Antares Rocket. So from separation to reach from separation to destructive reentry at the end of the mission, the Dulles team performs various operations, including initial vehicle configuration following insertion orbit, which include priming the propulsion system. They'll also have the solar array deployment as well that will be happening here with you soon here in about an hour and a half. And then they'll also be planning and executing various maneuvers to change Cygnus's orbit to rendezvous to the ISS. So that'll be continually changing throughout their maneuvers to get to the laboratory. And then there's also vehicle system checkout. So we continue to monitor the spacecraft as well to make sure it's healthy and everything is looking great on the spacecraft. And then at the end, they'll finally perform vehicle configurations to perform the final rendezvous as they arrive to the ISS.
And looking forward to Cygnus departure in November, Cygnus will perform some secondary operations. Can you go over some of those?
Yeah, so Cygnus actually has 2 secondary mission objectives for this NG-16 mission. After it departs from the International Space Station, There's one that is a passive payload from NASA called CREPI, and it stands for Kentucky Reentry Probe Experiment. And the payload will be loaded into the pressurized volume of the Cygnus with the disposal cargo items. And then the other payload is Purple, which is short for Prototype Infrared Payload. Purple is a Northrop Grumman built payload and will be tested and calibrated on while Cygnus's burst to the ISS. And the Purple payload actually requires 23 days of operations following departure to perform data collections and data downlinks. So we still have those two missions to complete after we are on berth from the ISS. So Cygnus has a lot of work of it ahead until here in November.
Thanks, Christina. Again, we are looking forward to welcoming Cygnus to the International Space Station, and thanks again for joining us.
Of course, thank you.
Guys, we are
and now joining us is NASA Systems Engineering Integration Office Manager Jeff Arend. Jeff, how important are these resupply missions in terms of the continuing resupply of this station and the science they deliver to the crew on board?
So I guess first off, hi, Courtney. But these commercial resupply missions are very important to continue the advancing science on board the station. Over 3,000 experiments have been conducted during the station's lifetime, which we're now coming up on 21 years of continuous human presence. On this flight, Cygnus is packed with more than 3,700 kilos of supplies, research, technology demonstrations, and hardware. In the tech demo category, we're really excited to add the 4-bed CO2 scrubber. It's an upgraded version of Seadra, which is our primary CO2 removal system on board. And for hardware upgrades, we're equally excited to be flying the third IROSA mod kit, which will enable a future solar array upgrade in the future.
All right, and what's ahead for the crew on station once Cygnus arrives in terms of capture, cargo operations, and science?
So the Cygnus spacecraft will arrive at space station in a couple days, Thursday, August 12th at approximately 5:10 Central Time. NASA astronaut Megan MacArthur will be primed to capture the spacecraft with the Canadarm2, and she's backed up by ESA astronaut Thomas Pesquet. Following capture, the flight controllers in Houston will command the installation of Cygnus on the Earth-facing side of the Unity module, will remain for about 3 months. The crew will stay busy unpacking and conducting these research activities with the first several days being extremely critical for several experiments. The ones in particular are cardinal muscle, anti-atrophy, and cell gravasensing. The crew will also be preparing for a future spacewalk to install the mod kit on the P4 truss to prepare the station for that future solar array upgrade that I mentioned earlier. In addition to upgrading the ISS power, these arrays are also helping us prove the solar array technology that will be used on the gateway around the moon with the Artemis program. So overall, very, very exciting times for us.
Okay.
Exciting indeed, Jeff. As always, thanks for your time and thanks for joining us today.
Yeah, appreciate it, Courtney. Thank you very much.
So indeed, this mission was a complete success for the launch part. Right now, Cygnus is in the space, coasting orbit, looking in for the rendezvous plan and finally rendezvousing with the International Space Station. So it will take around 2 days for it to rendezvous with the space station, and then it will stay there for around 3 months or so. After that, it will be stacked up with all the trash and everything, and then it will unberth from the station, go away from the station, re-enter the atmosphere, and burn up in the atmosphere.
Milestones today. The launch time today was moved to the back of the launch window after teams detected an apparent helium pressurization valve leak on the vehicle. The issue was quickly resolved and Cygnus lifted off from NASA's Wallops Flight Facility in Wallops Island, Virginia at the Mid-Atlantic Regional Spaceport Pad 0A on time at 5:01 and 5 seconds p.m. Central Time, 6:01 and 5 seconds p.m. Eastern Time to begin its journey to the International Space Station, where it will deliver more than 8,200 pounds of research, crew supplies, and hardware. At the time of launch, the International Space Station was flying 260 statute miles over the southern Indian Ocean. Solar array deploy is expected to occur about 1 hour and 14 minutes after launch. So within the next hour, if all goes as planned, Cygnus will complete its solar array deployment, which will take about 30 minutes. We will not be on air for that milestone, but once that activity is complete, we will update the station webpage on nasa.gov.
Cool. So, yes.
With Cygnus now on its way to the International Space Station, we hope you'll join us back on air when Cygnus arrives to the station in the early morning on Thursday, August 12th. NASA television coverage for Cygnus arrival and capture will begin at 3:45 a.m. Central Time, 4:45 a.m. Eastern Time, for capture around 5:10 a.m. Central Time, 6:10 a.m. Eastern Time. And then we'll be back on air at 7 a.m. Central, 8 a.m. Eastern for Cygnus installation operations coverage. With Cygnus now on its way to the International Space Station to deliver more than 8,200 pounds of cargo, that'll wrap up our coverage for today. This is Mission Control Houston.
Okay, so finally, let's just talk about the things we love to talk. Okay, so coming to your question, Wildflower, speaking of the gateway, what plans do they have to deal with the lack of magnetosphere protection? Well, okay, so this is a good question actually. So they will have to, consider their radiation protection plans a bit more aggressively. So they do need to, radiation harden everything on the spacecraft, not only for the, computers and everything, but if finally the humans will be going there, so radiation will be a big thing which will affect the humans on the moon. See, there are two types of radiation mainly, the cosmic galactic rays and the sun rays, the solar rays which comes out. The cosmic galactic rays are coming in from the cosmics all over cosmos. So, and the solar is what we know coming in from the sun. So the more harmful are the cosmic galactic rays, and we can protect ourselves, from the solar rays, but not from the cosmic galactic. They are very harmful and very powerful also. So you you can say that you need to be lucky at times when you are dealing with the radiations, because right now we don't have any as such instrument to predict when the solar storm will happen, or when the a cosmic galactic storm will happen, you kind of that. So we do need to, only thing which we can do is protect ourselves from radiation. We can do the there are certain substances which can be used for protecting us from the radiations. That is the silicon oxide layer on the spacecraft, that can be used. Then we have water is a very good radiation absorber, and it can shield us from the harmful events. It was devised also for the Apollo astronauts, that if there was some sort of solar storm or something like that during their journey, or during the landing on the moon, the astronauts will go inside a water shower kind of a thing, where they will be needed to shield themselves. And yeah, but eventually it was dropped, but yeah, that was one of the plans. So that was one thing. Yes, Sandeep, tomorrow is the GSLV Mark II rocket launch happening. I will be streaming that or two, so do come in, and we will discuss about that. ISRO is launching. ISRO is launching after so long. They had to deal with the COVID and everything. COVID actually hit them real hard, and now they're finally back on the track. Let's hope everything goes as per the plan for tomorrow's launch. Water is good, yeah. Are you covering any of that? Any of that? Thank you all so much for joining in, just being here and hitting the like button. Exactly, I don't know how many likes are there. Last I checked, there were like 99 likes. Have we got past them? 102, and okay. Can we get 150 likes? If you haven't, please like the stream, and we'll see. It's what the Navy uses to insulate nuclear reactors on their ship. Indeed, water is a very good absorber of the radiation. So Now looking in for so there have been certain activities which have have been there in the past 10 days or 11 days or so, which and the the show stealer is obviously the stacking of these starship with the super heavy. Wow, literally wow. That moment was truly exceptional. And although that the moment it was tagged, it was looking so good. I myself wanted to go there in the starbase and click some selfies, click some photos in front of it, but obviously I can't do that right now. But this is the monstrous, the as Elon says, the holy grail of rocketry, the starship. It is coming in, and finally it is coming alive. Finally it will be used for the orbital launch and everything. And talking about the orbital launch, well, there is something which we all know, that SpaceX is the sole contractor for the Artemis mission, right? And right now we got some regulations and some documents relating to the things which will happen with the HLS system, how that will happen. So it was like there will be around 16 launches of the Starship which will be needed to have one HLS delivery to the moon. So that is pretty large number. 16 launches would be needed for the one launch will be there, and then again I haven't read it fully, but I have seen that there will be 16 launches that will be needed, and then they will be able to achieve one HLS contract for the NASA. So there are like 14 tanker missions which need to be done in order to refuel the Starship in orbit. So now I can understand why Blue Origin was fighting so hard to get the contract. I mean, now it feels like Blue Origin was kind of right to have them also included in the contract, because 16 launches is, man, too much. Is too much. And Starship is still in the development phase, and we don't know whether they will be, and one the interval between the launches will be around 12 days. So it's not like it's Starship where you can as Elon claims that you can have a 1 hour or 2 hour turn around period for a Starship. And that is not the case for, at least for the HLS right now. It will be like 12 days intervals between the launches, and there will be 16 launches. Then finally one HLS mission will be able to perform. So 16 launches in 12 days interval. So how many days will be there? Check. 192 days, which is around 3 months. Wow, 3 months and 12 days. I haven't done the math. Now I did the math. This is I don't know if this is feasible or not. Like, you have to wait like 3 months to do one HLS launch. Not wait, but you are actually constantly doing all the launches to basically you require 3 months to do a one HLS launch. Yeah, that is the thing. says that delays in spacesuit development are another factor making a 2024 astronaut moon landing impossible, with for $20 million spent and another $625 million expected. Suits won't be ready for flight until 2025 at the earliest. So that's a bummer. We all know since spacesuits will not be ready, so obviously you can't expect humans to go to the moon by 2024, which was the expected date. So, and China is, coming in with all of with everything they have. They are also developing the suits. They are also developing the landers, the human landers for their lunar missions, and yeah, the race is going on. Yes, this was the thing which I was talking about. As addressed above, SpaceX concept of operation contemplated 16 total launches consist of one launch of its deleted, 14 launch of its tanker Starship to supply fuel deleted, and one launch of its HLS lander Starship. So there will be like 16 launches to do one HLS mission, which would be deleted and then travel to the moon. I don't know what this deleted is. Do you know what this deleted is? So you can see here it was like 16 launches. It will take around 16 launches, and I don't think so we have anything about the interval between the launches. No, but in another document we had the interval also. It would take 16 launches, 12 days interval, and around that means around 3 months and 12 days to do one HLS mission, and everything needs to go as per the plan. Wow, there are so much complication in this mission, and I don't know how will they manage it, and how the numbers suggest, but this is totally very complex, and Blue Origin was not, totally incorrect in their claims. So as they said, 10 plus Starship launches, yes. Initially we thought that it will take around 8 launches, but now the NASA document is out and it is taking 16 launches. Yes, it is kind of complex mission. It will take 3 launches only for the national team. So I wouldn't say that only give the contract to the Blue Origin and don't give anything to SpaceX. If Blue Origin was providing its own funding also to the NASA's Artemis mission, I think NASA should have given the contract to Blue Origin just to have 2 providers, obviously, and to avoid this much of complexity, because if any of the Starship launches fails, then what happens we don't know. Because see, this is like tanker missions will be there, like 14 tanker missions are to be done, right? And for refueling the Starship. So if any of the tanker missions fails, it is not able to perform perfectly and it fails or explodes during the ascent, then your Starship is in the orbit. Now it has to remain in the orbit until unless you figure out what was the reason of explosion for the tanker one. You have to resolve that, you have to get it approved, then again you have to launch it and then refuel it, and for all this time there will be propellant boil off that will be happening in the original Starship. So if there is any problem happens between the launches or the tanker missions, you will want more launches for the tanker then, because you would have boiled off all your propellants which tanker would have supplied. So that is one thing too. First deleted might be a landers supply few one launch of its lander. Okay. one launch of its, I think, the normal Starship, I guess. I think that should be it for today, and we will. Okay, so ISRO just tweeted right now. Countdown for the launch of GSLV-F10 mission commenced. Wow! See this image. This is so cool. I must admit that this, the photographer for ISRO. I don't know about the videography about for the ISRO, but this photographer for ISRO is like the best one which I have seen. Just see this image. Looks so good. So now the preparations for the launch have started, which we can see here. It's like T-1 day. You can expect the launch preparations to start. So at tomorrow around 24 hours from now, 24 and 25 hours from now, you should be seeing this GSLV Mark II launch happening. This is a very rare launch, and you will see some mark diamonds also. And talking about the rockets, I totally forgot about the question which I asked, the Baumgartner maneuver which happens uh, for this. Did you notice that slight tilt in the rocket when it just moved out of the pad? I noticed that, and that is what we call a Baumgartner maneuver. And it does that to it does that to get off from the launch pad. I mean, get away from the launch pad. So the exhaust coming out of the rocket engine is, very harmful, very, dangerous. Kind of, you can say that for the launch pad. So it performs that maneuver in which it gives a slight tilt just after the liftoff, so that it goes away at an angle, so that the plumes does not interfere with the launch pad as such, and you don't want to do much refurbishments for the pad. So that's why it performs that slight tilt to go away from the pad. That maneuver is known as Baumgartner maneuver. Thanks for another stream. Thank you so much, Andrew, for coming in. And tomorrow for the launch of GSLV rocket, which we will see. Yep. And yes. So I think we can end the stream right now. I love this picture. I totally love this picture. This does not feel uh, real, but it is actually real. I mean, yeah, photo editing will be there, but it's not like CGI or any type of artistic illustration. And the epic moment for since 10 days since I wasn't streaming. This was the epic moment. Starship full stack, and we can see people. Oh, Tim also here. Here you can see him. Um, you know, people coming in to just click photos and have a look to join in this historic moment for the Starship stacking. Imagine what will happen when they will fully recover the Starship, and then that recovered Starship will be stacked upon super heavy, recovered super heavy. That would be amazing to watch. Okay, I think guys, that's it for today, and I guess you enjoyed the stream, you enjoyed the animations. I did the animations today only in just like 1 hour 2 hour or so. It may not be totally perfect, but I tried to do my best. And tomorrow we have the GSLV Mark II launch. Do join me. It will be around 25 hours from now, and we will see what do we have in store for us for tomorrow's launch. Thank you so much guys for joining in, and consider it. Okay, I don't know what is that, but I will surely search it and try to make one for myself. Okay, thank you so much, Alfonso, for that appreciation. But tomorrow is the D-Day for me because that is the day which I have been waiting for so long. That GSLV Mark II launch is, was initially scheduled for March 2020, and now finally will be happening in 2021. So it will be interesting to see. So again, okay. Now it's the time I go to sleep. It's 4:30 around here, and now I should go and sleep, wake up, and give my exam again tomorrow. And let's hope everything well. Thank you so much for guys for joining in. And until then, this is Priyanshu Roila. You just saw Rocket Gyan. Stay safe, stay healthy, and bye.